Imagine looking up at the moon and seeing not just a pale, cratered sphere, but the twinkling lights of a functioning city. For decades, lunar colonies were the stuff of science fiction. But today, we are standing on the threshold of the most ambitious construction project in human history. Building on the moon isn't just about going further. It's about learning to build without the things we've taken for granted for 10,000 years. An atmosphere, a magnetic field, and easy access to water. The first rule of lunar construction is the rule of weight. It costs tens of thousands of dollars to launch a single kilogram of material into orbit. If we tried to ship steel beams and bags of concrete from Earth to build a moon base, the project would be bankrupt before the first floor was finished. This means we have to embrace in situ resource utilization, or, more simply, living off the land. The moon is covered in a layer of fine, gray dust called regolith. On Earth, dust is a nuisance. On the moon, it is our primary building material. Engineers are developing giant 3D printers that can land on the lunar surface and immediately go to work. These robots will scoop up the regolith, mix it with a binding agent, or use high-powered lasers to melt it into a solid, ceramic-like structure. We won't be shipping houses to the moon. We'll be printing them out of the moon itself. But a lunar building has to be more than just a shelter. It has to be a fortress. Without an atmosphere, the moon is bombarded by a constant stream of solar radiation and micrometeoroids. Tiny pebbles traveling at tens of thousands of miles per hour. To survive, lunar habitats will likely be covered in several meters of regolith or tucked away inside lava tubes. These are massive, natural underground tunnels formed by ancient volcanic activity. By building inside these caves, we gain a natural shield against the vacuum and the radiation of space. Then there is the problem of the dust itself. Lunar regolith isn't like sand on a beach, because there is no wind or water to erode it. Every tiny grain of moon dust is as sharp as a shard of glass. It gets into every seal, clogs every motor, and can tear through spacesuit fabric. Managing this dust is the greatest logistical challenge of lunar construction. Every entrance to a moon base will require sophisticated, electrostatic, cleaning rooms to strip the dust off of equipment and astronauts before they step inside. The second massive challenge is the day-night cycle. A single day on the moon lasts about 29 Earth days. That means you have 2 weeks of blinding, unrelenting sunlight, followed by 2 weeks of total freezing darkness where temperatures drop to -280 degrees Fahrenheit. You can't rely on simple solar power to survive a lunar night. Lunar builders are looking to the peaks of eternal light, mountain summits at the moon's poles that are almost always in sunlight, or developing massive, nuclear batteries to keep the lights on during the long, frozen darkness. What about the people? Working in 1/6 gravity changes everything about the construction site. A single astronaut can lift a massive beam that would require a crane on Earth. But there's a catch: inertia. That beam still has the same mass. If it starts moving, it's just as hard to stop as it would be in London or New York. Construction crews will have to learn a completely new set of physics to keep from being crushed by objects that feel light, but move with deadly force. Water and air are the final pieces of the puzzle. We've discovered that the moon's shadows, specifically the permanently shadowed regions at the poles, contain millions of tons of water ice. Lunar construction will involve mining this ice, not just for drinking, but to be split into hydrogen for rocket fuel and oxygen for breathing. The first lunar base won't just be an outpost. It will be a gas station for the rest of the solar system. Why go to all this trouble? Why build in an environment that is actively trying to kill us? Because the moon is the seventh continent. It is a platform for telescopes that can see the beginning of time without the interference of an atmosphere. It is a laboratory for low-gravity manufacturing that could create new medicines and materials impossible to make on Earth. And most importantly, it is our training ground. If we can learn to build on the moon, we can learn to build on Mars and beyond. Lunar construction is the ultimate test of human ingenuity. It is the moment we stop being visitors to space and start being residents. It is the transition from, the moon is something we look at, to, the moon is somewhere we go to. Work. The next time you see a crescent moon hanging in the evening sky, don't just see a rock. See a construction site. See the 3D printers carving out the first streets. The solar arrays capturing the unfiltered light of the sun. And the foundations of a future where humanity is no longer bound to a single planet. We have built under the sea and across the mountains. Now, it's time to build among the stars. As you look up at that gray